Myself Anushka, Assistant Professor, Department of Chemistry, ETME, College of Engineering, Mysore. Today I am going to conduct the experiment is conductometric estimation of acid mixture. Conductometer. It is defined as determination or measurement of the electrical conductance of an electrolyte solution by means of conductometer. The electrical conductivity of an electrolyte solution is depending on the number of ions presenting in the solution, the mobility of the ions, the temperature of the solution, and charge carried by the solution. So the conductivity is depending upon these factors. The principle of the conductometer. The presence of the ions is responsible for the conductivity of the solution. The conductance is mainly depending upon the ions or concentration. It is mainly depending upon the concentration, mobility and nature. The conductivity measurement can be employed to determine the end point in the acid-base titration. In the conductometer, we are going to conduct the acid-base titration. When the acid mixture, so the acid mixture is nothing but the mixture of HCl and acetic acid. One is the strong acid and another one is the weak acid, is titrated against the standard NaOH solution. NaOH is a strong base. When the strong acid gets neutralized completely before the neutralization of the weak acid, first the HCl is undergo for the neutralization and after that acetic acid undergo for the neutralization. Thus, the changing in the conductivity is observed due to the variation in the concentration and mobility of the ions. The concentration of the conductivity graph will be marked at the equivalence point. The first break corresponding to the equivalence point, the completely neutralized of strong acid, and the second break corresponding to the equivalence point of neutralization of weak acid. So this is the conductometer setup, this is the conductometer and this is the conductivity cell. So the chemicals and glass operators required to conduct the experiment: pipette, 25 cm cube of pipette, distilled water, standard NaOH solution, acid mixture. So already I prepared 4 different concentrations of the acid mixture, and beaker, conductivity cell, burette and conductometer. So first we have to wash the conductivity cell with distilled water. And fill the burette with NaOH, standard NaOH. So fill the burette. Initially the conductance is 0 and pipette out 25 cm cup of the acid mixture twice, because we have to pipette out 50 cm cube of the acid mixture into the beaker. First we pipette 25 cm cube of acid mixture into the beaker. Again, you have to pipette out 25 cm cube of acid mixture into the beaker. initial conductance of the solution. The initial conductance is 11.7. Note on the value without adding the titrant. Now we are adding the NaOH solution into the beaker and mix it well, and note down the conductance. The conductance is decreased. The initial conductance is 11.7. The second value is 8.3. The conductance is decreased while adding the NaOH solution to the acid mixture. After completely neutralization, the first equivalence point should be neutralization of the HCl. The second break is the equivalence point of acetic acid solution. After completely neutralization of the acid mixture, the conductance is gradually increases. Now we have to observe the increasing in the conductance after completely neutralization of the solution. So here we have to observe the increasing of the conductance. So the experimental observation in volume of K2's NaOH solution is added. It's added in the 0.5, 0.5, 0.51, 1.5. We have to note down the conductance here and float a graph. The graph, float a graph in the x-axis, the volume of NaOH solution. In y-axis is the conductance. So initially the conductance is increased. So after adding the NaOH solution to the acid mixture, the conductance is decreased. So here we have to observe the decreasing in the conductance after completely neutralization of the H plus ion. So it's a gradually increase. At a certain point, it's a second equivalence point. Here the acetic acid is completely neutralization takes place. After complete neutralization of the acid mixture, so the conductance should be increased. We have to observe in the graph. In the strong electrolyte, NaOH is undergo for Na plus and OH minus ion. Strong electrolyte is HCl. First, it is undergo for the equivalence point or neutralize the H plus ion, H plus plus Cl minus. Weak electrolyte is acetic acid. So here there is an equation. The HCl is react with NaOH. So we have to obtain the NaCl plus water. Acetic acid is react with NaOH. We have to obtain sodium acetate plus water. The final experimental calculation, the normality of the standard NaOH solution. We have already calculated the standard NaOH solution, and volume of K2SiO2O7 is consumed. It is taken from the graph. And after the estimation of the hydrochloric acid, so it is in V1, it is taken from the graph 1 and substitute values here, and the equivalent weight, already known the equivalent weight of the HCl is 36.5. So substitute the values and calculate the weight of HCl in 50 cm³ of solution. The similar way to that, here the estimation of acetic acid. The volume of NaOH is already obtained from the graph B minus A. After that, you have to obtain the volume of standard NaOH solution and substitute the values here. And already we know the equivalent weight of the acetic acid, and substitute the values and calculate the weight of acetic acid in 50 cm³ of solution. The final result is amount of hydrochloric acid in 50 cm³ of solution and amount of acetic acid in 50 cm³ of solution. Thank you.